Welcome to Monroe Tutoring. This is Molarity Part 2, and we're going to jump right in with the question, which is, what volume of 3.50 molar hydrochloric acid solution will contain 10.0 moles of hydrochloric acid? So in the last video, in part 1 of molarity, I defined what it is, which is, remember, molarity is a concentration, it's a measure of concentration, which is equal to the moles of solute over the liters of the solution. Now, in this problem, we are given the molarity and the quantity of moles that we want, and we're being asked for the volume. So just like I did in my molar mass videos, I'm going to rewrite the molarity as a conversion factor, whereas in the molar mass videos, I rewrote molar mass as a conversion factor. If we're trying to go between grams and moles, or between moles and mass, we use the molar mass, right? In this, when we have a volume or moles, and we're given the molarity, we can use the molarity as a conversion factor. Just like we did with molar mass, between moles and mass, we can use the molarity to go between volume and moles, okay? Same idea, and this is gonna make things easy because we can just kind of rinse and repeat for all these different topics in chemistry. We can just rewrite things as a conversion factor and use them to simplify the math and just do dimensional analysis for everything, okay? So let's jump in. We're going to rewrite this. Instead of 3.50 molars of HCl, remember, a molar is equal to the moles of solute over the liters of solution, okay? And so I'm going to rewrite this as there's 3.5 moles for every liter of solution, right? If it's 3.5 molar, that means that there's 3.5 moles of HCl and 1 liter of solution. So let's just write that. We have 3.50 moles of HCl for every 1 liter of the solution. And now we just took our molarity and rewrote it as a conversion factor. And now we can just do dimensional analysis to solve this problem. We don't have to flip around formulas. We don't have to memorize anything. We just plug things in and cancel units out, and the units tell us what to do. So, like I taught you last time, we take the given quantity and we put that to the left, and then we're going to make our parenthesis here in order to cancel out the units. So we are given 10 moles of HCl, and we open up our parentheses and we put our fraction bar, and then we take the molarity, rewritten as a conversion factor, and now we just plug it in here to cancel out the units. All right, some people memorize a triangle, and in my early days of tutoring, I used to actually teach that, but I realized people very easily misremembered how to put the variables in the triangle, so they would just get things wrong. Whereas if you just understand how to cancel units, it's really hard to mess it up. So let's do it this way. So I have moles of HCl, and I want to cancel them. So that means this part that has moles of HCl must go in the bottom, right? This unit here has to go down here to cancel out, like I taught you in my other videos. So let's do 3.50 moles of HCl. And on the top now is going to go 1 liter of solution. 1 liter of solution. And they're asking for the volume of the solution that we need in order to get 10 moles of HCl, if the concentration is the 3.50 molars. And by the way, that little AQ at the end of HCl just means aqueous, which is just indicating that the hydrochloric acid, that HCl is dissolved in the solution, in water specifically. So let's go ahead and just do this math now. We just write our equals, we cancel out the moles, and we're just going to plug this in. Remember, I never multiply or divide by the ones because it doesn't change the value. So we're just going to do 10 divided by 3.5. 10 over 3.5 is, there's actually quite a few decimal places, but let's think about how many significant figures we want. And again, if you don't know sig figs, check out my videos on that. There's 2 of them, but that has 3 sig figs, that has 3 sig figs. This is infinitely precise, so we don't count that. So we need 3 sig figs. So it's 2.857. I'm going to take that 7, round up the hundredths place into 2.86, and that's going to be liters of solution. And that's liters of solution. All right, guys? So not too bad. If you know how to do dimensional analysis and you've seen my videos on that and the other related topics, then this should be a cakewalk for you. You just have to know that we can rewrite the molarity as a conversion factor and then just put whichever side you need to on the bottom in order to cancel out the units of what you're given. All right, guys, if this helped, please give a like, follow, share, subscribe. Save this for later so you can review again, and I'll see you guys in the next one.